So in this video, I'm going to show you the solutions to the arithmetic reasoning subtest of AFQT practice test number 8. Again, this is a premium practice test, so this video will not appear on my YouTube channel. That said, let's go ahead and get started. Question 1 says, Martha spends $20 on materials with which to make earrings. She made 10 sets of earrings and sold 7 for $5 and 3 for $2. Write a numerical expression to represent Martha's profit, which will be denoted by P. So we have P equals, we know her cost to make the earrings is $20, so we're going to have to subtract that or take that away from what she sells them for. And we're told additionally that she sells one set for, or 7 sets for $5 and 3 sets for $2. And there we can see that that's the appropriate equation to represent how much profit she makes. It's right here. Not really anything I can explain more so than just showing you how it's done. Again, for some questions on the ASVAB, you just have to be able to take a word problem and write it as an equation. So that's that one. Let's go ahead and move on to number 2. And honestly, this practice test is much easier than AFQT practice test number 7. Last night I actually worked out the solutions to the arithmetic reasoning subtest on that practice test, and it was challenging for me. So just bear in mind that each of these practice tests vary. I try to cover the same concepts in different practice tests, but some of them turn out to be a little more difficult than others. So if you do poorly on one of them, just go ahead and take the next one. Chances are you'll do better on that one. So number 2 says, during a week in March, the temperature in Hoboken was 35 degrees, 36 degrees, 34 degrees, 38 degrees, 40 degrees, 39 degrees, and 44 degrees. What was the average daily temperature for the week? So to find the average, I like to remember it this way. Average equals the sum of all the observations over how many observations there were. That is, average equals some number. In this case, it's going to look like this. Average equals 35 plus 36 plus 34 plus 38 plus 40 plus 39 plus 44. And so that's the sum of all the observations. And there are 1, 2, 3, 4, 5, 6, 7 of them. Just double check. 1, 2, 3, 4, 5, 6, 7. So this is how we would find the average. Whenever I saw problems like this on the ASVAB, I knew as long as I didn't make a mistake doing the very basic arithmetic, this was a give me problem. So let's go ahead and work it out. Whenever I do addition, I like to do it vertically. 35, 36, 34, and take your time as you do the addition. Very easy to make a mistake doing this. There have been, I remember when I took the ASVAB, I was a little nervous because, it's a standardized test. And there were problems like this where I had to actually do this twice just to make sure I did it right. So if you get stuck here and things aren't working out and you don't find the answer choice, this is probably where you made your mistake. Everyone can make a mistake here. No one's perfect at arithmetic with a lot of numbers. That's why they invented calculators. So let's go ahead and work this out. I like to do the easy ones first. 6 plus 4 is 10, plus 5 is 15. 8 plus 9 is 17. 15 plus 4 is 19. So this is 19 plus 17, which is going to be 9 plus 7 is 6. Carry a 1, 36, so drop down the 6. Carry the 3. This side's a little easier. 3, 6, 9, 12, 15. So up to here we're 15. 15. 4 and 4 is 8. 8 plus 3, 8, 9, 10, 11. 11 and 15 is, let's work that out. 5 plus 1 is 6. 1 plus 1 is 2, so this is 266. So the average is going to be 266 divided by 7. Again, all fractions can be regarded as long division. So we're going to do off to the side here 266 divided by 7. 7 goes into 2. It doesn't. 2 is too small. 7 goes into 26 3 times. 7 times 3, of course, is 21. 26 minus 21 is going to be 5. Drop down this 6. 7 times 8 is 56. So we can see that there's no remainder. Therefore, we can conclude accurately that the average of the temperature in Hoboken, which is in New Jersey, is going to be 38 degrees. Again, this is kind of a give me problem. That said, even though it's a gimme, you have to do the addition as well as the long division accurately to get the answer to the problem. Okay? Let's go ahead and move on to number 3. All right, number 3 says, in the past, Jeff was paid $73,780 annually. Since switching to a new career, he has made $143,871 annually. What was the percent of increase in his salary? On the ASVAB, you're going to be asked to find percent increases and decreases, and I like to remember it this way. You always put it over the original, and you do big minus small over original, okay? And just to keep it the same, we're going to do new salary minus original salary over original. That's going to give you the percentage increase. So again, always the original number in the denominator, and then big minus small, okay? So in this case, that's going to look like this: 143,871. That's his new salary, minus 73,780 over 73,780. So let's go ahead and work this out. Again, we have 143,871 minus 73,780. Subtract. 1 minus 0 is just 1. 7 minus 8 we can't do. We have to borrow. This becomes 7. This becomes 17. 17 minus 8 is 9. 7 minus 7 is 0. 3 minus 3 is 0. 14 minus 7 is 7. So in other words, his salary went up by $70,091, and his original salary is $73,780. Now, the ASVAB is really a test of common sense and your comfort level with being able to make decisions in terms of rounding. If I were to do this long division, if I were to do that long division, it would take me a very long time and it'd be very taxing. What I'm going to do instead is, I know that fractions can be reduced to simple form, and what I'm going to do is round. I know that if I do 70 divided by 74, this will give me a percentage that's almost identical to this one. And beyond that, I'm going to go ahead and reduce this a little further. That is, I'm going to divide the numerator and the denominator by a common factor of 2. Just to make the math easier. I do not like working with big numbers. So again, this is where you would do the long division. I round it. I round it down, and just so you can see that, if I round it to 70,000 and 74,000, what I can then do is just kick off these zeros to make it 70 over 74, and now I can reduce this even further to be by dividing by 2, which I'm going to do right here. 2 goes into 7 3 times without going over. 2 times 3 is 6. Subtract. Drop down this 0. 2 goes into 10 5 times. 2 times 5 is 10. So there's no remainder. So I know 70 divided by 2 is 35. 74 divided by 2. 2 goes into 7 3 times without going over. 2 times 3 is 6. 7 minus 6 is 1. Drop down this 4. 2 goes into 14 7 times without going over. 2 times 7 is 14, so there's no remainder. And now we can see that this is the same as 35 over 37, which is very close to being 100%, but not quite there. So at this point, I'm going to look at my answer choices and see if I can work this out logically. 60% would be right around 2/3, which would be 20 over 30. Again, 66% is 2/3. This is a little less than that, so I know this isn't a reasonable answer choice. 110% would be something like this. 39 over 37, that is, the numerator would be bigger than the denominator, so I know this isn't an answer choice. This one is 35 over 37, which is very close to 1, but not quite 1. So this is a possible answer choice. This is 35 over 37, again close to 1. So this is a reasonable answer choice as well. So now I'm going to do the long division with this. But that said, I'm not going to work it out fully. I'm going to say this is either going to be 9 or 8. If 9 works, I know that the answer is going to be 95%. So what I got to do is ask myself how many times 37 goes into 35. 35 is too small, so I have to add a 0. In adding that 0, I have to add a decimal up there. Now the question is, how many times does 37 go into 35? Well, again, I'm using the answer choice, which starts with 9, to help me figure that out. So I'm going to do 37 times 9. 9 times 7 is 63. So we drop down the 3 and place the 6 above the 3. 9 times 3 is 27, 28, 29, 30, 31, 32, 33. So we can see that 37 times 9 is 333. So this is going to be 9, 333. And right away, I know that this is going to be 90 some odd %, which is the only answer choice that is in. There's only one answer choice in 90%. So I'm done. I'm not going to work that out fully. I did enough work here to figure out that this is the only reasonable answer choice. Okay, so if the long division isn't easy like it is here, be smart and use your answer choices to estimate the answer. That will save you a lot of time and stress. So let's go ahead and move on to another one. And again, I'm not going to work that out in this video. It would take me forever to do it. This test is timed. It's a test of common sense. You have to be able to start using the answer choices to guide your work. This is a fairly common answer choice type that or question that you'll see on the ASVAB. Number 4 says a math student scored 75, 70, 85, 90, 100 on the first 5 tests he took. After he took his 6th math test, the average is now 85. What did he score on the 6th test? So again, average equals the sum of the observations over how many observations there are. So that looks like this. 75 plus 70 plus 85 plus 90 plus 100. That's the first 5. We know he took a 6th test that we don't know the score of. So this is 1, 2, 3, 4, 5, 6, including the unknown test score. And beyond that, we know that after he took these tests, his average was 85. So we can actually fill in the average as well in the formula. Now we're just solving for x. Again, solve for x. That is, we want to get x by itself. The first thing I'm going to do is divide or multiply both sides by 6 to get rid of the fraction. This crosses out, and I'm going to do 85 times 6 over here. 5 times 6 is 30. Carry the 3. 8 times 6 is, let's see, 48, 49, 50, 51. So this is 510 equals 75 plus 70 plus 85 plus 90 plus 100 plus x. So now we're solving for x. We're going to combine all these numbers before we move them to the left. So again, we have to set it up like this. 100, 90, 85, 70, 75. And thankfully, this isn't as hard to do as the last one. 0 plus 0 plus 5 plus 0 plus 5 is just 10. So we have to drop down to 0 and add a 1. 9 plus 1 is 10. 10 plus 14 is 24. So this gives us 24 plus 8, which is 8, 9, 10, 11, 12. I'll carry the 1, 32. Drop down the 2, carry the 3. 3 plus 1 is 4. So we can see that 510 equals 420 plus x. Now we're going to subtract 420 from both sides. This crosses out. 510 minus 420. If you can't see this one, that's fine, but 420 plus 100 would give you 520. 420 plus 90 will give you 510. That said, let's work it out. 0 minus 0 is 0. 1 minus 2 we can't do. We have to borrow. This becomes 4. This becomes 11. 11 minus 2 is 9, and 4 minus 4 is 0. So we can see x equals 90, and so that is the correct answer choice right there. Okay, you will see questions like this on the ASVAB. You'll see questions in which you just have to find the average, and then you'll see another type of question in which the average is given. All the numbers except 1 is given, and you have to find that unknown number. So be prepared to find the average both ways. In the last practice test, AFQT 7, I also showed you how to find a weighted average. You may see that as well too. Okay, number 5 says, Kea drew a scale drawing of an auditorium. The stage, which is 30 feet wide in real life, is 6 inches wide in the drawing. What scale did Kea use? So we're told she used this. The stage is 30 feet wide, and in her drawing, that corresponds to 6 inches. 6 divided by 6 is just 1. 30 divided by 6 is 5. So the scale is 1 inch corresponds to 5 feet. Okay? All he did was use the scale that was given and then simplify it so that it's standardized in 1-inch increments. Okay? So that's that one. Fairly straightforward. Alright, number 6 is a basic probability problem. It says we have numbered cards from 1 to 20 and picked one at random. Find the probability that the card picked is numbered a multiple of 2 or 5. So we have 20 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The question is, what is the probability of picking a face value that's either a multiple of 5 or 2? Well, it's easy to figure out what's a multiple of 5. Anything that's a multiple of 5 is going to end in a 5 or a 0. We know 5 is a multiple of 5. 10 ends in 0, so that's also a multiple of 5. 15 ends in 5, so that's also a multiple of 5. And 20 ends in 0, so we know that's also a multiple of 5. As for 2, if anything is an even number, it's typically divisible by 2. 2 is divisible by 2, so that's a multiple of 2. 4 is divisible by 2. 6 is divisible by 2. 8 is divisible by 2. Now, here's the kicker. 10 is a multiple of 5 and 2, but for probability, we can't count twice. So if we counted this as a multiple of 5, we just have to know that it's also a multiple of 2, but we can't count it when we add up the probability. So it's there, but we can't count it, because otherwise we double count it. 12 is a multiple of 2, 16 is a multiple of 2, 18 is a multiple of 2. And 20, similarly, is also a multiple of 2. But since we're counting it as a multiple of 5 already, we can't include it as a multiple of 2. Otherwise, it would mess up our probability. So let's count up how many cards there are, which we don't have to do. We were told that there are 20 cards. But we want to count up how many multiples of 2 and 5 we identified. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I miss one? I did. I missed 14. Okay. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiples of 2. So the odds of picking a multiple of 2 or 5, and we're not double counting 2s or 5s, is 12 out of 20. That's not one of our answer choices because we can reduce this by a common factor of 2. That is, we can divide the numerator as well as the denominator by a common factor of 2. 12 divided by 2 is 6. 20 divided by 2 is 10. Again, we don't see that as an answer choice, so we have to recognize that this can also be reduced by another common factor of 2. 6 divided by 2 is 3. 10 divided by 2 is 5, which is right there. Okay? So, a more advanced probability problem insofar as you had to recognize that there's some overlap between multiples of 2 and 5, and when you do account for probability, you cannot double count. Okay, so that's that one. Again, on my website, I do have a mathematics formula sheet, which includes a fairly extensive section for probability. Take a look at that. I know I was never good at probability, so you may want to study that if you need to. Okay, number 7 says Paul can complete an inventory in 2 hours. Aaliyah can complete in the same inventory in 3 hours. If they work together, how long will it take them to complete one inventory? So this is a combined work problem, and you set up combined work problems the same way every single time. I introduced combined work problem in AFQT 7 arithmetic reasoning. If you want to see how I set up that problem, I set it up the same way I'm going to set this one up. You may see combined work problems on the ASVAB. I know that I've seen these type of problems over and over again because unless you've seen a couple of them, they're not clear as to how to set up. But that said, let's go ahead and do it. Let's start with Paul. Paul can complete an inventory in 2 hours. That means he can complete 1/2 of the inventory every hour. Aaliyah can complete the inventory in 3 hours. That means she can complete 1/3 of the inventory per hour. If we combine their rates of work, which would be with addition, we want to figure out how long it would take them to complete one inventory together. The only thing we're missing here is the variable time. Okay, so Paul works at a rate of half the inventory per hour. Leah works at 1/3 of the inventory per hour. So we just have to throw this variable time here, and now we can solve the problem. These are set up the same way every single time. You find out how much of something they can do per hour. You set that equal to 1, which refers to one inventory, and then you combine the fractions and solve for t time. You set these up the same way no matter what type of scenario they throw at you. And I like to simplify these fractions before I go further. And let me do that off to the side so you can see what I'm talking about. Right here I have 1/2 times t. If you're not good with fractions, this is what you're really doing. 1/2 times t over 1. To make anything a fraction, you just place it over 1. So if I wanted to make 15 a fraction, I would just do 15 over 1. If I wanted to make 36 a fraction, I would just place it over 1. Okay? Now, this is multiplication of fractions, so you just multiply straight across. That is, you do 1 times t and 2 times 1. So this is anything times 1 is itself, t over 2. Okay, so I like to take this t, just put it in the numerator using this rule right here. And I think in the AFQT practice test 7 video, I just did this step. I assume people knew this, but I'm breaking it down here for you. So I'm going to do the same thing here. This, without doing the work, is t over 3 equals 1. Okay, now we just have to put these fractions over common denominator, which is going to be 6. So we can add them together. 2 goes into 6 3 times, so I have to multiply this by 3 to make this denominator 6. What I do to the denominator, I do to the numerator, so this is 3t. 3 goes into 6 2 times, so I have to multiply this by 2 to get 6. What I do in the denominator, I also have to do in the numerator. 2 times t is 2t. Now I can add these together. 5t over 6 equals 1. Again, when you add fractions, you keep the denominator base the same, and you just add the numerators together. Again, this would be 3t plus 2t. If you need help with fractions, I have a whole video on fractions on my YouTube channel. Go ahead and check it out. Now we're solving for t, so I'm going to multiply this by the inverse, which is going to allow these two to cross out, and what I do to one side, I have to do to the other. This becomes t equals anything times 1 is itself, 6 over 5. We can see that 6 over 5 isn't an answer choice, So we have to be mindful of the fact that this is a fraction which can easily be converted to a decimal by doing long division. So we do 6 divided by 5. 5 goes into 6 one time without going over. 5 times 1 is 5. Subtract 6 minus 5 is 1. 5 doesn't go into 1, so we have to add an imaginary 0, which prompts me to put up a decimal right there. 5 goes into 10 2 times. 5 times 2 is 10, so there is no remainder. In other words, 6 over 5 hours is the same as 1.2 hours. In other words, it would take Paul and Aaliyah 1.2 hours to complete the inventory. Okay, you set these up the same way no matter what. A common problem is two pools draining, or a pool draining with two different pumps working at different speeds. Same way. Painting a house, one person paints it this fast, one person paints it this fast. Set it up the same way. They can change the parameters of the word problem, but you're always going to set it up this way. And of course the explanation said see video. I don't know how I would explain that with words. Alright, question 8 says Bill makes $24 per hour for a standard 40-hour work week. He earns time and a half for every hour worked over 40 hours during that week. If Bill earned $1,140 last week, how many overtime hours did he work? So we have to set up an equation to solve this one. It's a very basic equation. He made $1,140. We know that he gets paid $24 for every 40 hours he works. And we want to figure out how many overtime hours he worked. So to do that, we need to figure out what his overtime rate of pay is. And we're just told that he earns 1.5 times his regular rate of pay for anything over 40 hours. So I'm going to have to take 24 and multiply that by 1.5, which is the same as 1.5. We're multiplying a whole number by a decimal. So I'm going to have to take this decimal and shift it one place to make that 1.515. And so in reality, I'm doing 24 times 15, albeit with one decimal to shift back in at the end, which I moved right here. I'll add it back into the left right here. Let's work this out. 5 times 4 is 20. Carry the 2. 5 times 2 is 10, plus 2 is 12. Add a 0 since we're starting this number. 1 times 4 is 4. 2 times 1 is 2. 0 plus 0 is 0. 2 plus 4 is 6. 2 plus 1 is 3. Shift our one decimal back in. We can see that his overtime rate of pay is $36 per hour. And the question is, how many overtime hours did he work? Which I'm going to denote with an X right there. So let's go ahead and solve for X. I can work this out right here. 40 times 24. I can go ahead and take care of that right away. 0 times 4 is 0. 4 times 4 is 16. Add a 0 since we're starting this number. 2 times 0 is 0. 4 times 2 is 8. Let's go ahead and add those up. 0 plus 0 is 0. 0 plus 6 is 6. 1 plus 9 is... I think I made a mistake there. Let me double check this. 40, 24. 4 times 0 is 0. 4 times 4 is 16. Add a 0. 2 times 0 is 0. 2 times 4 is 8. 0 plus 0 is 0. 6 plus 0 is 0, 6. 8 plus 1 is 9. So we can see 1140 equals 960 plus 36x. Let's go ahead and keep trying to solve for x. So we're going to minus 960 from both sides. This crosses out. We're left with 1140 minus 960. Okay, I can't do 0 minus 6. I have to borrow. This becomes a 3. This becomes 10. 10 minus 6 is 4. 3 minus 9 I can't do. I have to borrow. This becomes a 0. This becomes 13. I know this is going to be 9, 10, 11, 12, 13, 4. And let's go ahead and keep working this out. This is going to be, let's see, 0 minus nothing is 0. 1 minus nothing is 1. What am I doing here? Let me start that over real quick. So this is 1140 minus 960. 0 minus 0 is 0. 4 minus 6 I can't do. I have to borrow. And I'm going to regard this as 11. So this is going to become 10. And this is going to become 14. I lined that up wrong in the last one. 14 minus 6 is 8. And 10 minus 9 is 1. So we have 180 equals 36x. And you can see that even though I've done a lot of arithmetic already so far, I can get tripped up on a problem if I misalign my subtraction, the numbers in my subtraction problem. So even though I'm pretty good at math, I like to think I'm pretty good at math, the ASVAB is hard because you have to do addition, subtraction, multiplication, and division with decimals, fractions, whole numbers over and over again, pretty much for the whole section of the test. And you're bound to run into a problem where you're second guessing your work, which I just did. But as I just did, you just have to rewrite it and double check your work and move on. So even the people who are great at math are going to have to do that. So now we have 36x equals 180. Going to divide both sides by 36 to just get x by itself. This crosses out. We're left with x equals 180 divided by 36. If you want, you can reduce this. I can see that both of these are going to be divisible by 6. 6 goes into 18 3 times with a 0 left over, so this is going to be 30. And 36 is divisible by 6. Again, I'm just doing that quickly in my head. 36 is divisible by 6 times. So to solve this one, we can see that it's going to be 30 divided by 6, which is just 5. Okay, so a lot of work for this problem. A lot of subtraction and addition and multiplication. But ultimately, it turned out to be pretty straightforward once we wrapped our head around it. So there's that one. All right, number 9 says there are 512 blades of grass in each acre of land, and a section of land has 5 to the 4th acres of land. How many blades of grass does the land have? This is a good question because some people would go 5 to the 12th is the same as 5 times 5 times 5 times 5 times 5. you know, 12 times. Now, that's not how you do this problem, obviously. This is testing your knowledge of the laws of exponents, which, more specifically, it's testing your knowledge of this one. A to some power n, or m, times a to some power n is the same as a to m plus n. I think that's the multiplication rule for the laws of exponents. And in this case, to find out how much grass there is in 5 to the 4th acres of land, we do this 5 to the 12th times 5 to the 4th. Okay, and using this law of exponents, it becomes very easy. This is 5 to the 12th plus 4, which is the same as 5. 12 plus 4 is 16. So we can see there are 5 to the 16th blades of grass and 5 to the 4th acres of land, assuming that there are 5 to the 12th blades of grass in each acre of land. Okay, so that's that one. All right, number 10 says a lawn sprinkler sprays water 5 feet in every direction as it rotates in a circle. How much area of the lawn does it water? So here's the sprinkler. Again, it's spraying water in a perfect circle. And we want to figure out how much area it covers. Again, it's spraying it in every area, so we can get the radius pretty easily. We know that's going to be 5. Based on the information given in the question. Now we just have to recall how to find the area of a circle. That's pi r squared. It's one of the formulas you need to know in order to do well in the ASVAB. And as a reminder, whenever you deal with pi on the ASVAB, you always let it be 3.14 since you're working out things by hand. So let's plug things in accordingly. I'm going to leave pi in there for now until we get ready to do the arithmetic. The radius, as we identified already, is 5 squared. 5 squared, of course, is 25. Again, 5 squared is the same as 5 times 5, which is 25, in case you needed to see that. Let's go ahead and get ready to use 3.14 for pi times 25. And as you can see, we have one final step of arithmetic to solve this one. Namely 3.14 times 25. Again, we're doing multiplication with a whole number and a decimal. To make it easier, I'm going to shift this decimal 2 decimal places. So in reality, I'm doing 314 times 25, albeit with 2 decimals to shift back in at the end. So let's go ahead and get started. Hopefully I don't make any mistakes, but if I do, I'll probably catch them. 4 times 5 is 20, carry the 2. 5 times 1 is 5, 6, 7. 5 times 3 is 15. We're starting this number, so we have to drop down a 0 before we begin. 4 times 2 is 8. 2 times 1 is 2, and 2 times 3 is 6. Let's add. 0 plus 0 is 0. 7 plus 8 is going to be 15. Carry the 1. 5 plus 2 is 7. Plus 1 is 8. And 6 plus 1 is 7. Okay? 2 decimal places to shift in. 1, 2. So we can see our area is going to be 78.5 feet squared, which is right there. Okay, so that's that one. Nothing too challenging in that one. So let's go ahead and move on to the next one. So we got to deal with some more fractions here for number 11, which says Dana and Megan have to fill 500 envelopes for charity. At the end of the morning, Dana has filled 3 out of 20 of the envelopes, and Megan has filled 1/4 of them. How many envelopes have they filled together? So again, we're told Dana has filled 3 over 20, and Megan has filled 1/4 of them. Again, we want to figure out how much they filled together, but we have these fractions which have different denominators. That said, we should recognize that we can easily put 4 over denominator 20 by this. Let me show you. 4 goes into 25 times, so to make this denominator 20, I would multiply that by 5. And what you do to the denominator, you do to the numerator. So 1/4 is the same as 5 over 20. Now we can simply add these. Again, when you add fractions, you keep the denominator the same, and you just add the numerators. So this is going to be 3 plus 5, or 5 plus 3 is 8 over 20. We can reduce this if we'd like to make the math easier. I know 4 goes in 8 as well as 20, so I can divide those both by 4, which would be 2 over 5. So, in other words, they filled 2/5 of the envelopes together. Now we just have to figure out what 2/5 of 500 is. So, we can do it this way, 2/5 times 500. And again, when you multiply fractions, you multiply straight across. Again, when you add fractions, you just add the numerators. When you multiply fractions, you multiply straight across. So this would be 1,000 over 5. And we should be able to see that 1,000 divided by 5 is going to be 200. Again, if you couldn't see this in your head, let's work it out right here. 1,000 divided by 5. 5 doesn't go into 1. 5 goes into 10 2 times. Just bring up those zeros. You know 5 times 200 is going to be 1,000 with no remainder. So to answer the question, we see that combined they filled out 200 envelopes. So that's that one. And even though these questions are not that difficult, they still take a lot of mental resources to do. Again, you have to do a lot of mental math, a lot of arithmetic, and that's what really makes this section of the test challenging. All right, number 12 says Rosita buys 300 feet of yarn for a craft project. If the yarn costs 12 cents a yard, how much does Rosita spend? Right away, you should recognize that she buys 300 feet of yarn, but the costs are given in, where's it at? Yards. Again, she bought 300 feet, but the costs are given in yards. So we have to make a conversion at some point. I'm going to make the conversion right here. This is very easy to do. There are 3 feet per yard. So to convert feet to yards, I would do 300 divided by 3, which would be 100. So 300 feet is the same as 100 yards. We know the yarn costs 12 cents a yard, so this becomes a multiplication problem, namely 100 times, and again, $1 would look like this in decimal form. $1.12 would look like this in decimal form. So to do this math, we would do 100 times 0.12, which refers to 12 cents. And as it happens, this math is pretty easy to do. Whenever you multiply something by a power of 10, which includes 10, 100, 1,000, 10,000, million, and so on, all you do is take this decimal and shift it according to how many zeros there are in the power of 10. In 100, there's 1, 2 zeros. So we'll take this decimal and shift it 1 2 times. So I know 100 times 0.112 is just going to be 12, which we should recognize as $12. Okay, so that's that one. Couple more problems and we'll be done with this one. Alright, 13 says an aquarium has a base length of 12 inches, a width of 5 inches. If the aquarium is 10 inches tall, what is its total volume? So if you need to, you can sketch this one out. Again, we're dealing with a rectangular prism. Okay, we know its base is 12 inches. We know it's 10 inches tall, and it's going to be 5 inches wide. So in other words, we're trying to find the volume of this aquarium. Volume of a rectangular prism is simply length times width times height. We're given all three of those things. Length is 12. Again, this is how long the aquarium is. Its height is right here. That's 10. And its width is right here. That's 5. So this is going to be 12 times 5 times 10. Let's go ahead and work this out. 12 times 5 is 60 times 10. 60 times 10 is 600. So we can see that the volume of this aquarium is going to be 600 cubic inches. Again, right here, you could have used what I just showed you in the previous problem. You have 60 times 10, which is a power of 10. There's 1 0 in 10. The decimal place is technically right there. Shift it one time to get 600. Okay? So that's this one. Nothing too hard there. You just had to know the formula to find the volume of a rectangular prism. And you should memorize that one if you haven't done so already. Alright, number 14 says Platteville is 80 miles west and 60 miles north of Quincy. How long is a direct route from Platteville to Quincy? In case you need it, I don't know what they teach in schools nowadays, so I'll put the compass up here. North, south, east, and west. Let's go ahead and map this out. Platteville is 60 miles west. Let me get rid of this mark I made right there. So Quincy, I'm going to denote as Q. It's right there. Platteville is 80 miles west, so that's this way. And that's a straight line. And 60 miles north, which is this way. So here's Platteville in relation to Quincy. How long is a direct route from Platteville to Quincy, which would be, and I'll make this as a dashed line right there. We should recognize that this is a right triangle that they've given us. And again, this is going to be 80 and 60. And we want to find the direct route, which I'm going to denote as C right here. To do this problem, we have to know that this is the hypotenuse of the right triangle, which is directly across from the right angle. So we're going to make use of the Pythagorean theorem to solve for the hypotenuse. And the Pythagorean theorem is a squared plus b squared equals c squared, where c, of course, refers to the length of the hypotenuse, and a and b refer to the length of the legs, which are 60 and 80 respectively. Let's plug those in. 60 squared plus 80 squared equals c squared. Now, I don't know about you, but as I've mentioned already in this video, I do not like working with big numbers. I'm going to take away a 0 right here to make the math a little easier. And then once I solve this problem, I'll just tack a 0 back on. So this, in other words, what I'm saying would be 6 squared plus 8 squared equals c squared. 6 squared would be 36. 8 squared is 64 equals c squared. 36 and 64, it turns out, is 100. And if you needed me to work that off to the side, I can. 6 plus 4 is 10. Carry the 1. 6 plus 3 is 9. Plus 1 is 10. So 100 equals c squared. We take the square root of both sides. This crosses out. We're left with c equals the square root of 100, or c equals 10. Again, I took away a 0 here to make the math easier. Let me tack it back on. So this would be 100, which is right there. Now, alternatively, let me pull this over here. You could have kept the zeros, and as long as you're good with mental math, it's no big deal. 6 squared is 36. Therefore, 60 squared is going to be 3600. 8 squared is 64. Therefore, 8 squared is going to be 6400. And then again, we're solving for c squared, the hypotenuse. If you add these together, this gives you 10,000 equals c squared. Again, we'll take the square root of both sides. This crosses out. We're left with c equals the square root of 10,000. Square root of 10,000 is 100. 100 times 100 is 10,000. Okay, so I like working it out this way, but you could have done it this way as well. The math worked out pretty easily either way. So that's that one. All right. Number 15 says Mr. Beard's temperature is 98 degrees Fahrenheit. What is his temperature in degrees Celsius? We're given this formula, so all we have to do is plug it in and work out the math accordingly. So we're given C Celsius equals 5/9 Fahrenheit, which we're told is 98 minus 32. Again, as long as you know PEMDAS, the order of operations, that is the order in which you work out these problems, it's not too hard. You do what's in parentheses first, exponents next, multiplication and division from left to right, and addition and subtraction from left to right. So this becomes, so according to PEMDAS, we do what's in parentheses first. That would be 98 minus 32. 8 minus 2 is 6. 9 minus 3 is 6. So we can see we have 5/9 times 66. Now we can go ahead and look for exponents. There are none. Multiplication and division. We do have multiplication as our final thing to do. Specifically, we have 5/9 times 66. Let me work that off to the side. Okay, we're doing 5 times 66 and 9 times 1, because when you multiply fractions, it's multiply straight across. 9 times 1 is just 9. 5 times 66. Let me work that off to the side here. 6 times 5 is 30. Carry the 3. 6 times 5 is 30. Carry the 3. That's going to be 33. So this is 330 divided by 9. And again, I like reducing things before I do the long division. I know 330 and 9 are both divisible by 3. So I'm going to divide this by 3 and this by 3 before I proceed to the long division. And again, in case you can't see it, 330 divided by 3. 3 goes into 3 one time, 3 goes into 3 one time. Just bring up that 0 since there are no remainders. So this becomes 110 over 9 divided by 3 is 3. This is 110 divided by 3. I'd much rather do this than this. Okay? So to solve it, I'm going to do 110 divided by 3. And now we can actually work on the log division, which is going to be very simple. 3 goes into 11 3 times without going over. 3 times 3 is 9. 9 minus 11, 9, 10, 11. That's 2. Drop down this 0. 3 goes into 20 6 times without going over. Oh, I think I may have made a mistake here. No, I'm good. 3 goes into 26 times without going over. 3 times 6 is 18. Drop this down. This drops down to 20 minus 18 is 2. We add a 0. So now we're working with the decimal. 3 goes into 26 times without going over. 3 times 6 is 20. So we can see that this is going to repeat. That's a bad 6 there. To be 36.666666. And accordingly, it looks as if they just rounded 36.66. Repeat it to 36.7. Okay, so that's it for that one. And occasionally, when you work on the real ASVAB, there are going to be questions where they rounded the answer choice, and you just have to be mindful of that. You probably didn't do it wrong. If you're very close to a number, chances are they just rounded it. Okay, number 16, the final problem says at 4 p.m., two train, I gotta put an S there. At 4 p.m., two trains begin traveling towards each other. If they are 900 miles apart, the rate of the first train is 72 miles per hour, and the rate of the second train is 78 miles per hour. At what time will they meet? Okay, so whenever I see problems like this, I recognize that I'm dealing with the essential ingredients of the distance formula: distance, rate, and time. 900 miles is distance in my mind. A rate of 72, got a rate of 78. And the question is, what time will they meet? So I got my T right there. So I can recognize that we have two rates. I'll call this rate 2 and rate 1. I have a distance and a time. Now I have to figure out how I can use these numbers and the distance formula to solve this question. And if you need to, you can do a little sketch. You have a train going this way, and that train, of course, is going toward this train. And those are, let me fix that. That should be a straight line. So two trains are headed on the same track toward each other. T1 is going 72, and train 2 is going 78. The question is, at what time will they meet? And again, they're 900 miles apart. So this distance between train 1 and train 2 is 900 miles. These are combined rate problems, and once you know the trick to solving them, they get really easy. And the trick is this: instead of regarding these as two trains going toward each other, you want to think of it as one train going the same distance, 900 miles, albeit at a combined rate of both trains. So rate 1 plus rate 2, which would be 72 plus 78. So we'll call this train 3. It's traveling this way at 78 plus 72. 8 plus 2 is 10. Carry the 1. 7 plus 7 is 14. Plus 1 is 15. This is train 3 going at 150 miles per hour. The math is going to be the same. Okay? So as long as you can make the logical leap from two trains heading to each other at differing speeds being the same as one train going a combined rate of both trains but the same distance, these problems become very, very easy, because now you've gotten rid of that second rate variable. You combine them to make one rate. All you're doing is solving for time. Again, we know our distance is 900. We know our rate is a combined rate of 150 miles per hour, and we want to figure out what the time's going to be. So we're going to solve this by dividing both sides by 150. This crosses out. We're left with 900 over 150 equals t. Again, I do not like big numbers, so I'm going to kick off these zeros. And I'm running out of space on this one, which is why I'm kind of moving all over the place. 90 over 15 equals t. Okay. If you can't see this, again, it's always good to know your multiples of 15. 15, 30, 45, 60, 75, 90. 90 divided by 15 is going to be 1, 2, 3, 4, 5, 6. Okay, so in other words, it takes these two trains 6 hours to meet in the middle. So we have to add 6 hours to 4 p.m. So that's 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. In other words, they'll meet in the middle here at 10 p.m. Okay? So again, that's that one. And that's it for this video. I hope you found the explanations helpful. Again, I could produce videos in which my work's perfect. I don't second guess myself and everything lines up beautifully. That's not reality. Reality is you're taking this test under time constraints, so your work's going to be constrained, and that's what I like to portray in my videos. So that's it for this one. Again, this video is not going to be posted publicly. Thank you for subscribing with a premium membership, and I'll go ahead and upload the solutions to AFQT Practice Test 9 very soon.